Hello everyone, welcome to Equal To, and this is the third episode of our Polynomials playlist. I hope you have watched the past two videos yet. If you haven't, please go and watch them. Now, we have already covered the first two questions of our exercise 2.1 and we also solved example, right? Now, we are continuing with the exercise 2.1 and we are going to solve the rest of the questions in this video. Starting out with third question. Right, let me just read you the question first. So, give one example each of a binomial of degree 35 and a monomial of degree 100. Okay, so they are basically asking you to give a couple of examples. One is of a binomial of degree 35 and another one is of a monomial of degree 100. Right, so you have to note these two things, binomial and monomial. So what exactly are these terms? So we haven't discussed them so far. The name of the chapter is polynomials, but what the definition that we have given for polynomials is algebraic expressions with coefficients and variables, right? This is what we saw in the first video of this playlist. Now, the thing that we haven't mentioned yet is that the word poly here means it can have many terms. Okay, this expression can have many terms. Okay, so that is what they mean by poly. So with that said, you can come up with the definition for binomial and monomial, right? So binomial is basically, you guessed it right, it's two terms, and monomial is only one term. Okay, so you're supposed to generate expressions with two terms and one terms and having a degree of 35 and 100 respectively. Okay, so let us first give an example of a binomial, right? So for a binomial, it has to have two terms, right? So let me just take the first term. Let the first term be x power 35. Okay, so why x power 35? Because they want the degree of this binomial to be 35. Okay, so the degree should be 35. So degree is the highest possible exponent of a expression, right? So degree is 35 in this case. So for this expression to have degree 35, the other variables here should have exponent value lesser than 35. So let us say we have x power 12. Okay, so we have x power 35 plus x power 12. Now in this polynomial we have 35 as the degree, right? 35 here is the degree because that is the highest power, right? So that is the degree, and it of course is a binomial. Why is that? Because it has only two terms, right? So this is a binomial and it has a degree of 35. Now there can be multiple binomials with the same description. Okay, let me just write to another example. So we'll take blue. Okay, so 12x power 35 plus 14. This is also a binomial with its degree 35 and has only two terms, so it of course is a binomial, right? So this is also another example, and you can think of any number of examples for that matter that meets these requirements, right? So we are done with this binomial part. Now the second question or the second example that they want is a monomial of degree 100. Okay, so monomial is basically single term, right? So it should have only one term. Let us take y power 100. This is a monomial because it has only one term, and the degree is of course 100 because that is the only term here and it has the power of 100, right? So it's a monomial. Now there can be multiple monomials with the same description, like it can be 12 y power 100 or y power 100 divided by 2, or what else, root 2 y power 100, anything, right? So all these are monomials with degree 100. Okay, so that is it. I hope you got this question. It's very simple. You just have to know these two things. One is a binomial has two terms, monomial has one term, and we obviously know what a degree is, that we have seen already. It's the highest exponent power, right? Now we are moving to the next question of this exercise, which is the fourth question, and let me start with reading the question out. Write the degree of each of the polynomials. So this question is very similar to the example question that we solved in the previous video. Okay, so you can just work out the answer in your mind along with me. It's very simple. So let me just list out the exponents here. So this is 3 and this is 2 and this is 1, right? Even in the previous question we saw what degree is. So degree is the highest exponent value, right? So here the degree is 3. Okay, since x cube is the highest exponent here, the degree is 3. Moving on to the second subdivision, it's y minus x square. Here the degree is 0 because 4 is basically 4 into x power 0, right? X power 0 is 1, so it becomes 4 into 1 and that is 4 here. Okay, so here the degree is 0 and here the degree is 2, and 2 obviously is greater, and that is the degree of this polynomial, right? I think I told degree earlier, so it's exponent. The exponent of 4 is 0, the power of y squared is 2. Exponent or power, basically they are same, right? So power of y squared is 2 and the degree of this polynomial is 2 again. We are moving to the third subdivision. It's also again very similar to what we have seen. It's basically same. I think by this time you would already have gotten the hang of it and you'd know the answer by now. Anyways, I'm going to tell it, right? So here the power is 1 and here the power is 0 because so we basically have x power 0 here, so the power is 0, and since 1 is greater, so that would be our degree, right? Moving on to the last subdivision here, so we have 3, right? So 3 is basically 3 into x power 0. Okay, so that says that the degree of this polynomial is 0 because we have no other term with higher exponents. Okay, so that is all for this question. You just have to know what degrees are. I think we are clear with that by now. So this is very simple as well. Moving on to the last question of this exercise. With this we are coming to an end of this exercise and also this video. So let us just go through this question very quickly. Classify the following as linear, quadratic and cubic polynomials. Okay, so we are going to classify them as linear, quadratic or cubic. So what are linear polynomials? Linear polynomials basically mean the exponent is, or rather the degree is 1. When the degree is 1, it's called as linear polynomial. Okay, now a quadratic polynomial is something that has degree 2, and a cubic polynomial, it's right, it has a degree 3. Okay, so that is how you set them apart as linear, quadratic and cubic, right? Basically the degree of the polynomial. Degree 1 is linear, degree 2 is quadratic and degree 3 is cubic. Okay, now with that said, we are just going to rush through these subdivisions and mark them as linear, quadratic or cubic. Okay, the first one here has a degree 2, right? It has a degree 2. So this you can say it as quadratic. I'm just going to mark it as cube, right? Okay, I'm not going to write degree in all subdivisions. We can just go ahead. Now in the second thing we have x cube, right? So the degree is 3. So it's a cubic polynomial. The third subdivision we have y square and the degree of this polynomial is 2. So it's a quadratic polynomial. In the fourth subdivision we just have 1 plus x, and in 1 plus x, x's power is just 1. So you can tell it is a linear polynomial. And 3t also, the power of t is 1, so it's a linear polynomial. R square we have squared, right? So it's obviously a quadratic polynomial because it has a degree of 2. And 7x cube is obviously a cubic polynomial because it has a degree 3, right? So that is all. It's very simple. You just have to know what quadratic, linear and cubic expressions are. With that you can easily solve this question. Okay, so with that we have completed the first exercise of our polynomials chapter. So I hope you would have understood these things. If you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.